Questions 21 through 25 on the 2018 Grade 8 AMC 10B. Mary chose an even 4-digit number n. She wrote down all the divisors of n in increasing order from left to right, 1, 2, ... n over 2, n. At some moment, Mary wrote 323 as a divisor of n. What is the smallest possible value of the next divisor written to the right of 323? So we have this number n, and we don't know what it is, but one thing we know for sure is that 323 is a divisor of that. So 323 is broken up into the following prime factors: 17 times 19. So n obviously has to have 17 and 19 in its prime factorization. So 1 times something something. And we are told that n is a 4-digit number and that it's even. Because it's even, then it must have 2 as one of its prime factors. So that's what we have so far. Now, the remaining prime factors we don't know yet, but one thing we do know is that it's a 4-digit number. So the largest it could possibly be is 9999. And so far, we know the 2, 17, and 19 are prime factors. So if you take 9999 and divide by 2, 17, and 19, you get approximately 15.4. So that means that whatever prime factors are here, when they're multiplied together, they have to be less than or equal to 15. And they obviously have to be an integer. Okay, so now we've got to play with this. Let's go through the answer choices. First one is 324. 324 is 2 times 2 times 3 times 3 times 3 times 3. Okay, well, the only way to get that, we already have the 2, so all of these guys would have to go here. And that's way bigger than 15. So 324 is most likely not the correct answer. How about 330? That is 2 times 3 times 5 times 11. Okay, well, the 2 is already covered, but then 3 times 5 times 11 would have to go here, and that's much greater than 15. So that's not going to be possible. How about 340? 340 is equal to 2 times 2 times 5 times 17. Okay, well, the 2 is there, the 17 is there, so that means the 2 times 5 goes here, and that's 10, and that is indeed less than 15. And they want the smallest, so since we've already established that 340 would be possible, we don't need to worry about these two since they're bigger and we want the smallest. So just to make this question complete, n is actually 2 times 2 times 5 times 17 times 19, which is 6460, which is indeed an even 4-digit number. So number 21, the answer is C. Real numbers x and y are chosen independently and uniformly at random from the interval 0, 1. Which of the following numbers is closest to the probability that x, y, and 1 are the side lengths of an obtuse triangle? Well, you can have a right triangle and you can have an obtuse triangle. What is the difference? It all has to do with the angle. So, for example, in the first one, this is obviously a right triangle. We put x here, y here, and 1 here. Now, x and y are chosen in this interval. So that means that 1 is going to be in the hypotenuse. The reason I'm confident that 1 is the hypotenuse and x and y are the legs is because x and y are chosen in this interval. So x and y are always going to be between 1 and 0, like that. So at most, x can be 1. So x can never be greater than 1, and therefore the hypotenuse, the maximum value for the hypotenuse is 1. So that's why this is the scenario. Obtuse triangle just means that that angle is going to be greater than 90 degrees. So this is x, and this is y, and this is 1. So this is the scenario that we want. Well, the first thing from the triangle inequality is that x plus y has to be greater than 1. That's the only way a triangle can be made. And then from Pythagoras, x squared plus y squared is equal to 1 if it's right. But if it's an obtuse triangle, then x squared plus y squared has to be less than the hypotenuse, which in this case is 1. So we now have to essentially plot this, and our interval. So let's do that. The first thing, of course, is to plot the interval, and x and y are both going to be chosen from that interval 0 to 1. So this is 0, this is 1, this is 0, this is 1, and this is 0.11. So that box is basically our interval. Now let's plot this guy. X plus y is greater than 1. That can also be written as y is greater than minus x plus 1. So that is actually a line that you can easily plot that when x is 0, y would be 1, and when y is 0, x is 1. So it's actually a line that goes through here, like that. And since we want y to be greater than minus x plus 1, it will be this region right here, like that. And then the next thing that we need to graph is this guy right here, which is x squared plus y squared is equal to 1. And that, of course, as I'm sure you know, is just a circle. It's a circle of radius 1. So it will look like this. And x squared plus y squared is less than 1. So it'll be this region right there, less than 1. So that is the region we have to find the area of. They satisfy all of our conditions, the interval and these two equations. Okay, well, that seems like that area is a quarter of the circle, which would be this guy right here, minus this triangle. So a quarter of the circle, pi r squared divided by 4, minus 1/2 base times height. The base is 1, this is the base, that's 1, and this is the height, that's 1. So 1 times 1. So that looks like pi r squared, and r is 1 also, so that's going to be 1 squared over 4 minus 1/2. So that looks like pi over 4 minus 1/2. And if you use 3.14 for pi, you'll get 0.285 approximately. And of the answer choices, the one that's closest is C for number 22. How many ordered pairs AB of positive integers satisfy the equation a times b plus 63 is equal to 20 times LCM of AB plus 12 times the GCD of AB, where GCD denotes the greatest common divisor of AB, and LCM denotes their least common multiple? Well, I want to illustrate a few things with a little bit of an example first. Let's say A is 12 and B is 18. Well, 12 is 2 times 2 times 3. B is 2 times 3 times 3. Now let's calculate the least common multiple. The least common multiple looks like 2 times 2 times 3 times 3. So that would be 4 times 3, which is 4 times 9, which is 36. Now let's calculate the GCD, the greatest common divisor. What number goes into both? And I think that is going to be 3 and 2. 3 times 2, which is 6. So the LCM is 36 and the GCD is 6. Now note, this is not just true for this example, but it's true in general, that the LCM multiplied by the GCD will be equivalent to the two numbers multiplied by each other. So in this case, it was 36 times 6. A times B is 12 times 8. 36 times 6 is 216. And 12 times 8. 12 times 18 is also 216. So this is something that we definitely are going to use in this question, a very important finding or property. So let's move forward. We can move forward with this equation right here. The first thing I'm going to do is let LCM of AB equal to X, and I'll let the GCD of AB equal to Y. When you do that, and you also use that property, AB becomes just XY plus 63 equals 20 times X plus 12 times Y. So I've taken this equation and substituted these properties. Now this equation is something we have to work with. Let's put the xy on this side, minus 20x minus 12y, and on this side we will put the minus 63. Now I'd like to factor this, and I can do so by introducing 240 to both sides. Whatever I add on one side, I have to put on the other side. Now this side factors very nicely. xy, 12, and 20, and it'll be minus and minus. And on this side, 240 minus 63, which is 177. Now 177 can be written in a couple ways. The first, of course, is just 1 times 177. The other way is 3 times 59. So this and this can be equated in a few ways, and as follows. So we have a few scenarios here. Either x minus 12 is 1 and y minus 20 is 177. That would give me x is 13 and y is 197. So my xy here would be 13 and 197. Another way of doing it is x minus 12 is 177 and y minus 20 is 1. This would give me x equal to 189 and y is equal to 21. So this is 189 and 21, this xy. And then now we start looking at those two. That means x minus 12 could be 3 and y minus 20 is 59. This gives me x is 15 and y is 79. So 15 and 79. And then the other one is x minus 12 is 59 and y minus 20 is 3. So x is 71 and y is 23. So we have 71 and 23. Okay, so we've got some possible values for x and y. Now we have to figure out which one of those is actually going to work. Now note, x must be a multiple of y. What is x? What is y? X is LCM, y is GCD. X must be a multiple of y. Just like over here, x or LCD, or LCM I should say, was 36 and the GCD was 6. As you can clearly see, 36 is a multiple of 6. So in the same way, this LCM, which is x, must be a multiple of this GCD, which is y. So x must be a multiple of y. And of these findings here, the only one in which x is a multiple of y is this one right here. So 189 and 21 is the only xy that will work for us. So that means our LCM, our least common multiple, is 189, which is x, and that is 3 times 3 times 3 times 7. And our GCD is 21, and that is 3 times 7. So now we can figure out A and B. A and B. The LCM of A and B was this number right here, and the GCD of A and B is this number. Well, the greatest common divisor obviously has to be part of both numbers. So both numbers have 3 times 7, which is 21. Now we have to figure out, how do we get an LCM of that? The only way is to have a 9 attached to one of these, and the other one would not have the 9. So either one of these scenarios, 379 or 371, and then the other guy would be 379. You can't put 3, 7, and 3 like this, because if you did, the LCM would not be this. The LCM would just be 3 times 3 times 7. It would be just that much. So the only way to get the LCM of 3 times 3 times 3 times 7 is to have these two scenarios. So A and B, it looks like we have just 2. Either this for A and this for B, or this for A and this for B. So there's only 2 possible pairs. And therefore, the answer to number 23 is B. Let A, B, C, D, E, F be a regular hexagon with side length 1. Denote by X, Y, and Z the midpoints of sides A, B, C, D, and E, F respectively. What is the area of the convex hexagon whose interior is the intersection of the interiors of triangle ACE and triangle XYZ? Here we have our hexagon. Let's label it now. A, B, C, D, E, F. And then we have some midpoints here. X, Y, and Z. So here's X approximately, and then Y would be here, and Z is the midpoint of EF, so approximately here. And then now we have to draw in our triangles. So the first one is ACE. So ACE is this triangle right here. And then the next triangle would be XYZ. So X, Y to Z, like that. And then now they're saying that the intersection is basically our area that we have to figure out the value of. And that would be this right here. This is that intersection that we have to figure out the area of. Well, how do we do that? What I'm going to do is label all these sections, and hopefully it will make sense. This triangle I will label A, and because of the symmetry of this diagram, this is also A, and so is this. This triangle in here I will label B, and because of the symmetry of this diagram, this is B, and so is this. And then this triangle I will label C, and this is C, and this is C. And then the big one, whatever shape that is, I will call D, like this. So that interior, this interior right here, that we have to figure out, is basically calculated as follows. It would be that area, would be the area of the full hexagon, minus, we count now. And I've noticed that every letter was put in 3 times, so it's going to be 3 times A plus B plus C plus D. And if I can figure that out, I'm done with the question. Now the good news is there's a formula for the area of the hexagon. It is, I'll write it up here. Area of a hexagon is 3 root 3 over 2 times A squared, where A is the length of the side. In our question, the length is 1. So that helps us out tremendously, because now our full area of the whole hexagon is 3 root 3 over 2, and A is 1, so A squared would be 1. Now I have to figure out this 3 times A plus B plus C plus D. Well, this part right here, this section that is pretty much like a trapezoid, is C plus A plus D. So those 3 letters, C plus A plus D, I can calculate, And then later, I guess individually, I'll calculate b. So let's concentrate on c plus a plus d. I'm going to label this distance, let's call it w, and this distance right here I will call v. And this is a 90-degree angle, and the way this is drawn, this is also a 90-degree angle, and the internal angles of a hexagon are 120 degrees. So if this whole thing is 120, that means this in here is 30, and therefore this in here is 60. And the side was 1, so from here to here, since z is the midpoint, will be a half. So this will allow me to calculate v and w. So here we go, using similar triangles. So now let's calculate those values, v and w. The first one, let's say w, over a half, using the 30, 60, 90 triangle, is the same as root 3 over 2. So that means w is root 3 over 4. And then using the v side, v over a half is the equivalent of 1 over 2, and therefore v is a quarter. So now we can easily figure out the area of that trapezoid. If I draw a perpendicular from D to the other side, like that, hopefully that will make it clear to you that this side is equivalent to this, which is 1, the same as the side of the hexagon, plus v plus another v, since that is also going to be v due to the symmetry of the diagram. So our trapezoid is going to be c plus a plus d, and that is going to be ed, which is just 1, plus this side, which looks like 1 plus 2v, all over 2, and then times the height, which is w. And using our formula and our values, we have 2 plus 2v, which is 2 plus a half over 2, and then w is root 3 over 4. So this looks like 5 over 2 times a half times root 3 over 4, and that looks like 5 root 3 over 16. So 5 root 3 over 16 is a plus c plus d. So let's go back and substitute that in. We've got 3 root 3 over 2 minus 3. And then this a plus c plus d is 5 root 3 over 16. So now all we have to do is figure out that b. And I think that will complete the question. So where is b? B is right here. All right. Well, the way this is drawn, this is obviously a right angle. And we have to do a little bit of angle chasing here. This was also a right angle, so since the internal angles are 120, this is going to be 30, this angle right here. And then this is a right angle, so this is going to be 60. Therefore, this has to be 120, but this line cuts that in half. Or even if that wasn't obvious to you, it should be obvious that that's 90, since internal angle is 120, this is 30. This was drawn in a way so that was a right angle, and therefore this angle in here would be 60. And then therefore that is 30. And then this is going to be 60 degrees. So there we go. We've got another 30, 60, 90 triangle. And just to make things a little obvious, I'm going to draw a line directly from A down to D. And not perfectly drawn to scale, but if it was, you would be able to clearly see that this triangle is essentially in this half of the hexagon, since this cuts it exactly in half. This triangle is on the other side, and this line cuts that part in half, and because this is the midpoint and so is the x. So that means that this line is cut in half, and therefore this triangle is essentially a mirror reflection of B. So that means B is equal to C. So all of that just to prove that B is equal to C. So this B is equal to C. So all I have to do is figure out the area of C, and I'm done. Here's C right here. We had already figured out the dimensions. 1/2 base times height would be the same as 1/2 W times V. 1/2 W was √3/4, and V was 1/4. So this is √3/632. So there we go. We got all the pieces of the puzzle. Let's put that in there then. Instead of this B, we know B is equal to C, and C is √3/32. So now I just have to add this all up. 3√3/2 minus 3, common denominator top and bottom by 2. I'd get 10√3 plus √3, which is 11√3, and the denominator is 32. So this is going to be, if I get a common denominator again, top and bottom by 16. So 48√3 minus 33√3 all over 32, and that is 15√3/32. 15√3/32 is the answer to this challenging question, number 24. The answer is C. Let x bracket denote the greatest integer less than or equal to x. How many real numbers x satisfy the equation x squared plus 10,000 x bracket is equal to 10,000x? So we have x squared plus 10,000 bracket x is equal to 10,000x. Let's bring the x squared to the other side. So this side would become root x is equal to 10,000 x minus x squared, and therefore now I can divide through by 10,000, and it's going to leave me with just x minus x squared over 10,000. All right, now what is x? I am not sure, but x is an integer part plus a fractional part, correct? So therefore, if I take the bracket x, it becomes just the integer part. That's basically the definition. So for example, 4.3, if that's x, if I take the bracket of that, it just gives me 4. So substituting that in here, this becomes I. This is I plus f, and this is just, I'll just leave it as x squared over 10,000 for now. Now the i's cancel on both sides, and therefore if I bring the x squared over, I get the fractional part is equal to x squared over 10,000. Now the fractional part, obviously it's between 0 and 1. So that means that this x squared over 10,000 is obviously less than 1, but greater than or equal to 0. Multiply through by 10,000, and we get x squared is less than 10,000 or greater than or equal to 0. And therefore x is going to be between 100 and negative 100. And therefore x could be minus 99, minus 98, dot, 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 all the way to 0. And then dot, 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 all the way up until 98 to 99. Now that gives me, if you count up those integers, 199. And for each value of x bracket will correspond to one value of x. Now this question is a little confusing because x is a real number, right? Real number x. X, they don't specify as an integer. X bracket is an integer. But apparently, for every value of x, you get one corresponding value of x bracket. So as we can see, the solution seems to be invalid at first, but one cannot determine whether x is an integer or not, right? Because x, they're just saying, is a real number. However, it actually works because although x itself might not be an integer, it is very close to 1. So there are therefore 199 potential x. So I kind of racked my brain on this because I said, okay, this is great if x was specified to be an integer, but x is being told as a real number. But apparently, if you read this, we can assume that because x is very close to an integer, we just look at the integer values. And therefore, when you count up all of them, you get 199 such values. So therefore, number 25, the answer is C.